So, and this is going to go into your grade 12. So we're going to make sure you have a solid understanding of your basic trig ratios from grade 10, your Pythagorean theorem from grade 8, grade 9, and then we're going to talk about labeling triangles. So trig, dealing with triangles and the angles in them, sides and angles. We have tangent, sine, and cosine. They're called the primary trig ratios. In grade 12, we're going to add 3 more onto that. Okay, so in grade 12, we're going to add 3 more, and they're related to those, but they're not the same. All right. Let's do our trig formulas. I don't know where we're going to put them. This seems like a good space. So sine of theta is equal to, what's the formula for sine of theta? Opposite over hypotenuse. Beautiful. And I'm just doing the abbreviations because, well, hypotenuse is a really long word to spell. And the next one is cos theta is equal to adjacent over hypotenuse. Now, if you ever forget them, they are at the back of my room. I have them on the board. They're that important, and they will be important in grade 12. Well, they'll be important for a lot of things. So tan is equal to what? Opposite over adjacent. So we're just going to leave those there just so that you remember. One thing that I find my students, and you know my big fan of notation, one thing I find that students often forget in this is they lose the theta. And I'm saying theta with a TH. So we're going to go into our Greek alphabet here. So it's just like a circle with kind of a line through it, a loop at the top. They're the Greek alphabets up there. Yeah? Pardon? No, theta is just it can be any variable. But I find that angles, we usually represent them by Greek letters. So theta is our general one. We like to use alphas. And we like to use beta. And beta is a B with like a tail on it. So those are my Greek alphabets. We usually use these to represent an unknown angle. I know sometimes when I'm pronouncing theta, you don't get the TH in there. But literally, it's just a circle, and then I loop through. That's how I make a theta. Alpha is kind of like a fish, and beta is a capital B with a little curly Q. So those are the ones. It doesn't mean you can't use an X or a Y to represent. It's a variable. So there's nothing special about them, but these are usually the Greek letters that we use. And you probably used theta last year. You might just not have known it. So this is a variable. It's just a Greek letter. And in math, we often use like pi is a Greek letter in the Greek alphabet. So we use that symbol to represent unknown things, but they tend to be angles in this case. So I find a lot of people drop this off. They say sine equals opposite over hypotenuse, but it's sine of the angle. That's the angle is equal to opposite over hypotenuse. Okay, so that's kind of like the whatevers. Angles of triangles are labeled with capital letters or Greek variables. So there's that Greek variable up at the top there. We're going to talk about the capital letters and lowercase letters. When we name the sides of a right angle, it's in relation to one of its acute angles. Holy Hannah, that was a lot of stuff to take in. Okay, so acute angle. What's an acute angle? Less than 90. Okay, so an acute angle is less than 90. So when we're looking at this triangle here, they've indicated that A is our angle. Okay. I want to hold on for a second. I want to draw a pretty picture. You guys ready for this? This is my right angle triangle I'm about to draw you. I know you're excited about it. And you guys know that a box in the corner represents 90? Yeah, everybody's got that? And you guys know that a horizontal line meets a vertical line at 90 degrees, right? These are I'm just going through. So when we go to label a triangle, this is one of the most important parts because you won't be able to do this unit if you don't know how to label triangles properly. So the vertices, when I say vertices, what are they? It's a mathy word. The points of the triangle, the corners of the triangle. Vertices are the angles, and they are labeled with capital letters. And it can be any capital letters. So if it is a capital letter, it's an angle. So capital letters represent angles. You guys with me with that? Those are my initials, by the way. Okay, capital letters. Now, the side across from its angle so the side opposite to the angle is labeled with the lowercase of that letter. Okay? So the hypotenuse of this triangle, would you guys all agree that the hypotenuse is KS? Like from K to S, this would be the hypotenuse. But in a triangle, it would be side A, and we'd label that with a lowercase a. It's not adjacent, it just matches its vertice letter. Okay? And so K, side K, would be there. I guess I should have picked better letters. And side S would be there. So lowercase are your sides, uppercase are your angles. Okay? You have to know how to label a triangle appropriately because we're going to start getting outside of right angle triangles and we're going to start using the sine law and the cosine law, which are formulas. So if you don't know what side A is or you don't know where the side is or what side we're talking about, so you have to be able to label a triangle. So lowercase we use for the sides. Uppercase we use for the angles. All right, everybody good with that? Okay. So that's important, super duper important. If I give you, we'll go to the next question in a second. Okay, the hypotenuse is always the side across from the right angle. So these are types of sides. These aren't their names, these are types. So the hypotenuse, what else do we know about hypotenuse? There's something special about the hypotenuse. It's the longest side. And opposite is across from the indicated angle, and adjacent is the side that's right next to the indicated angle. All right. So let's go to this question number 1 here for a second. So do you guys know what side I'm talking about when I talk about DE? In this case, it would be the hypotenuse, right? Let's add a letter to that. What lowercase letter would that be? F. And I always use cursive F's for my lowercase f's just because I'm a big fan of function notation. Okay, EF, what side would that be? Yeah, it would be the opposite, but what letter would that be? That would be side D. And then side DF would be letter E. Okay? All right, now we're going to actually answer that question. Which side is adjacent to angle D? So when those questions happen, angle D. Notice it's using the capital letter. And that little symbol there is the angle symbol. There's a difference between them. The angle symbol is horizontal and then a line, and then the greater than is kind of angled, like both of them. It's just so you know the difference. So angle D, I always like to indicate it. It's indicated here. So what side is adjacent to it? DF. All right, that's good. Which side is opposite to P? Opposite to angle P. Which one? MN, because it's angle P. PN would be my hypotenuse, and so the side right across from it would be my opposite. So that would be the answer. I think you guys are pretty good about labeling sides. Are we good with that? Yeah? You guys can do it? So if I do this really quick, this side is the opposite. That's the adjacent. You guys all knew that, right? Because the indicated angle is down here. And this one over here, indicated angle is now up here. So this one used theta. As you can see, theta is being used here for the angle. And what letter is this one? It's the alpha. It's the Greek letter alpha. So this one now becomes my adjacent side, and this one becomes my opposite side. All right. Okay. I think this is all just the stuff I went through already. Okay, we know how to use our calculator buttons? Do we know how to use our calculator buttons? So do you all have a calculator with you? Okay, so in grade 11, we're only going to use degrees. So you need to make sure that your calculator is in degrees. And how you do that is if I grab this calculator and turn it on. See up here, it says radians. It says rad, so that's for radians. That's another type of angle measurements. We're not going to do that. So I'm going to go over into degrees. Some of you may have a different button. You might have an R or a D or a G. Please make sure that it's either DEG or it's just the D on your calculator screen. Every calculator is different, so please make sure you know how yours works. First, so before we do any trig, we're going to make sure that the degree symbol is on there. Okay, so looking at this triangle, if you know that angle N is 55 degrees, if angle N is 55 degrees and you have 4.2 and you're trying to solve LM, so that just means you go from vertex L all the way to vertex M. So I'm trying to solve for that side. What trig ratio would I use? Sine, are you sure? I love it. I love the confidence. I love trig because you guys are all solid in it. So if you're unsure, I would make sure I label the side that's given and the side I want, and this is the opposite. So I'm looking for the trig ratio that has opposite and a hypotenuse in it, which is sine. So let's go ahead and actually solve for that right now. So let's set it up. So we know that sine of angle N is equal to opposite over hypotenuse. No, you don't always have to write out the formula for me. I think you guys have experience with this, so you might feel comfortable, but we're going to fill in what we know. Sine of 55 degrees. Do we know what opposite is? No. Are we going to give it a letter? What letter? Go to your triangle. What letter is it? A lowercase n. And the hypotenuse is 4.2. So what am I going to do to solve for n? N's already by itself. I need to get rid of this divide by 4.2. Brilliant. But whatever I do to one side, I have to do the other, because those will end up canceling each other out. So then here's the question. In your calculator, do you put the 55 first, or do you put the sine first? And for me in this question, I put the sine first. I'm going to close that bracket. Sometimes I like to figure out what it is. Remember, you have to use all the decimal places. So I would recommend you don't write them down. You just leave it like this. And then in my calculator, I'm going to say times by, so it's taking the answer from the previous line, times by 4.2. And we'll round to 2 decimal places. So this is going to be 3.44. And what are my units on this one? Centimeters. Do you guys feel comfortable with that? It's grade 10 all over again. It's coming crashing back at you. Okay. This is kind of the same question. Let me look. RT. No, this one's a different question. So let's do this one. So we're trying to find RT. That there. Sometimes I find highlighting it or indicating it is helpful, because then I know what I'm looking for. So when I start off this question, the first thing I'm going to do is I'm going to identify the sides I have. So here's my angle. So the 4.2 is going to be my adjacent side, and my RT will be the hypotenuse. Hypotenuse is always across from the right angle, and the adjacent side touches the angle. So I know this is my adjacent side. So would I use cos or sine here? Cos. Notice I didn't label my other side to confuse myself. The 2 pieces of information, the side I'm looking for is this one here. This is my question mark. All right, so let's set this up. So cos of 50 degrees is equal to the adjacent side 4.2 over the hypotenuse. What letter am I going to use for that? Lowercase s, which looks an awful lot like my uppercase s, and which sometimes looks like a 5. So I try not to use s's when possible. Okay, so this one, I don't know. You can know the math behind it. You can cross multiply. You can do that sort of thing. But I know when my variable's on the bottom, it ends up becoming a divide question. I switch these 2 places. So s is going to equal 4.2 divided by cos of 50 degrees. So here's the thing, ladies and gentlemen. This will be where calculator comes in handy. This calculator is pretty flush. It's got some options, so I can do it all in one step. I can go 4.2 divided by, but now I have to use brackets. Divided by cos of 50, close the angle bracket, close my denominator bracket. So my calculator will do it all in one step. I don't know if yours will. And we're going to round to 2 decimal places again. And I think we're centimeters as well. How do we feel about that? Good? Okay, how does your calculator work? Did you try it in your calculator? I'm showing you the answer so that you can try it in your calculator in a safe environment. And I hope you all can figure out how to do that in your calculator. If you're unsure, you can always do cos of 50. And then you can go 4.2 and divide by, and then if you've written that down on a scrap piece of paper, then just type it all in. It's the longer way to do it, but it is the okay way to do it. And you get the exact same answer. What do you mean?
What did you do? You don't have to use code?
I did. I did cos of 50 as its own line.
Oh, okay.
And then I just put it into 4.2 divided by that.
Oh, okay.
All right. Okay.
What about the hypotenuse?
I'm just looking. I don't think we need to do anything else on this. I think we're good. I think we're golden. Pythagorean theorem, you guys did pretty good on that. That's shown up on your tests and quizzes a few times. So I think everybody's good with that. Trig review assignment, you don't have to do it. I might make you do one question on it, just to be difficult. I'm gonna stop this video just for a second.